Here we have a SAT math question. There is a right triangle given over here, that is ABC. In the figure shown, AD equals to 121 over 3 and AB equals to 11 times square root of 130 over 3. What is the length of for DC? So the length of this line segment is given, that is 121 over 3, and the length of this line segment AB is given, that is 11 times square root of 130 over 3. We have to find the length of DC. Okay, it's a little tricky question. Okay, let me explain the idea on how to find the length of DC. Okay, now what I'm going to do is I'm just going to find the length of the altitude BD of the right triangle ABC. I'm saying BD is altitude because BD is a line segment which is perpendicular to the base of the triangle AC. So because there is a right angle over here. So I have to get the length of the altitude BD. Once I get the length of the altitude BD, I can use geometric mean theorem to find the length of the required line segment, that is DC. Okay, let me explain you the geometric mean theorem little later once I get the length of the altitude BD. So how do we have to get the length of this altitude BD? So here, since BD is altitude, it is perpendicular to the side, base AC, and here we have right angle, on the right, in this side also we have a right angle. Now let's consider the right triangle ABD over here. So in this right triangle ABD, AB represents a hypotenuse because it is opposite to the right angle over here. And the remaining two legs are AD and BD. I know the length of the hypotenuse, and also I know the length of one of the remaining two legs AD, that is 121 over 3. So using these two lengths, I can find the length of the side BD using the Pythagorean theorem. So what does the Pythagorean theorem say? Pythagorean theorem says that the square of the hypotenuse equals to sum of the squares of other two legs. So here AB is the hypotenuse, so AB square equals to sum of the squares of other two legs, that is AD square positive BD square. So I am writing this Pythagorean theorem in the right triangle ABD. Okay, we know the length of AB, that is 11 times square root of 130 over 3, that we can plug in for the AB over here. So 11 times square root of 130 over 3, the whole square equals to, and also we know the length of AD, that is 121 over 3, the whole square positive BD square. Okay, now in this equation we have to solve for BD, so which represents the altitude of the complete triangle ABC. Okay, now we have an exponent for a fraction. Whenever we have an exponent for a fraction, what we need to do is we have to distribute the exponent to numerator and denominator. Okay, then I'm going to take this exponent 2 for the numerator, then I'm getting 11 times square root of 130 the whole square over, and also I'm taking the exponent 2 for the denominator, then I'm getting 3 square. So the same thing we have to do over here, that is 121 square over 3 square equals to, positive BD square. Okay, now two values are multiplied and we have the common exponent too. So whenever two values are multiplied and we have a common exponent, the exponent can be distributed to each value and multiply the results. So that is 11 square times square root of 130 the whole square over the evaluation of this 3 square is just 9 equals to, now let's evaluate this 121 whole square. The evaluation of this 121 square is 14,641 over the evaluation of this 3 square is just 9 positive BD square. Okay, now the evaluation of this 11 square is 121 times, so the square root and square root cancelled, I'm getting 130 over 9 equals to 14,641 over 9 positive BD square. Okay, let me continue the stuff over here. Okay, now let's multiply this 121 and 130. When I multiply them, I'm getting 15,730 over 9 equals to 14,641 over 9 positive BD square. Okay, now my aim is to find the value, length of BD. So for that I have to get rid of this value 14,641 over 9. So for that I subtract both sides by 14,641 over 9. Okay, let me do it. So when I subtract them, this one will cancel out, and I'm getting on the left side, on the left side I'm getting 15,730 over 9 negative 14,641 over 9 equals to BD square on the right side. Okay, now we subtract two fractions with the same denominator, so we can take the common denominator 9, and we have to subtract the numerators, that is 15,730 negative 14,641 equals to BD square. Okay, when I subtract these two values, I am getting 1089 over 9 equals to BD square. 1089 over 9 results 121 equals to BD square. Okay, so since our aim is to get the length of BD, we can take square root on both sides. So when you take square root on both sides, the square root and square will cancel out. And the square root of 121 is just 11. So we get BD is equal to 11. Okay, now I got the length of the altitude over here, that is 11. I mean the length of the BD is 11. Okay, so now we got the length of the altitude of the triangle ABC, that is 11. Now we can use geometric mean theorem to get the length of this DC. Okay, let me erase the other stuff. Okay, now let me explain you the geometric mean theorem in a right triangle. Okay, we know the length of the altitude BD in this right triangle ABC. Now I consider the complete triangle ABC. This is also a right triangle. ABC is a right triangle because we have right angle at B. Okay, so geometric mean theorem says if we draw altitude from a vertex to the hypotenuse of a right triangle, so then the length of the altitude BD must be equal to the geometric mean of the two line segments we have on the hypotenuse. Here we have the two line segments AD and DC on the hypotenuse. Okay, so now the length of the altitude BD equals to the geometric mean of the two lengths of the two line segments AD and DC. So how do you have to find the geometric mean of the lengths of the two line segments AD and DC? It's very simple. We just have to multiply AD and DC, and for the product we have to take square root. So this represents a geometric mean of the lengths of the line segments AD and DC and the hypotenuse. So this is called geometric mean theorem in a right triangle. Again, I am saying the geometric mean theorem in a right triangle says the length of the hypotenuse drawn from a vertex to the hypotenuse must be equal to the geometric mean of the lengths of the line segments on the hypotenuse. Okay, we know the length of BD over here, so that is 11. We can just now we got it. We can plug in 11 for BD, and the length of AD is already given in the question, that is 121 over 3 times DC. DC is unknown, that is what we have to find. Okay, now to get out the square root over here, what I'm going to do is I'm going to square both sides. So when I square both sides, I'm getting 11 square on the left side. On the right side, we have square for this complete stuff. Then we can cancel the square root and square. So the evaluation of 11 square is 121. On the right side, I'm getting 121 over 3 times DC. Okay, since our aim is to find the length of DC, we have to get rid of this fraction 121 over 3. For that, I multiply both sides by the reciprocal of this one, that is 3 over 121. Let me multiply on the left side. That is 3 over 121. So when I multiply both sides by the reciprocal of this one, so this 3 will cancel, this 121 will cancel out, and here 121 will cancel out. I'm just having 3 on the left side. On the right side, I'm getting DC. Now I got the length of DC, so that is 3.